this eigen can be a capability of self-improvement, and it can become more competent than initial knowledge alone might allow. And by the learning agent, based on type of feedback, we have feedback here, and based on feedback, we have three kind of learning. The first is supervised learning. It means that we have the correct answer for each example, and the second is unsupervised learning. It means that no correct answer not given. And the mix between the supervised learning and unsupervised learning, we have the semi-supervised learning. And the last year, reinforcement learning is means that the occasional reward. Yeah, take a look about the based on the feedback, we will divide to the three kind of learning: supervised learning, semi-supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Yes, for four kind of learning. Yes. And here is we see the machine learning here. We have supervised learning, unsupervised learning, and reinforcement learning. In the supervised learning, we have the classification or regression, and in the unsupervised learning, the clustering or dimension reduction. And here the figure describe how the machine learning works. From the input data, we will find the pattern or analyze data and learn from the feedback, prediction, or the decision here. And we will take a look inside about the framework machine learning algorithm support vector machine at VM. This algorithm is a high dimensionality and memory efficiency, as well as versatility. How the SVM work? We had two classes here, and now how to divide two classes? How to find hyperlink to divide two classes? And here describe with the class not like that is in regression, and how we change from the regression to non-regression. Yeah. And with the when we apply the performance class at VM, how the VM works. It means that we can divide one class to other, and from that we can find what's the best class for classification. Yeah. It means that in the VM we had to find the best hyperplane. It means we had to solve this equation. And we had to find the maximum mean by this formula, and we will find the two parameters here, W and B. By quadratic programming solver, we can apply using CVX OPT. Here is step by step, but we have chaining data, and we build the V from chaining data, and like we calculate T by the formula. We have the result here, and next step we increase the P vector. It's our own one vector, and G is a diametric for own lambda equal greater and equal than 0. Yes. And we build a matrix here. And next we build I means that the transform of Y matrix. And we build B, and we apply K, P, G, H, I, B to equation, and we find the lambda. And apply lambda xy to this formula, we get the result here. And from the W, we find the B. When we find the W and B, we can know that the size of the value here. And here is the top 10 algorithm you should know for the engineer. The first is naive bias, the second G-mean, the third is the talk before ITM, and the fourth is the a priori association rule. The next is linear regression, and after that is logistic regression, decision tree, random forest, TNN, and artificial neural network. We will talk later. What is artificial neural network? Here is the biological neuron. We have biological neuron with the dendrite, nuclear, axon, and how to neuron act. And from the biology neuron, we had build an artificial neural network. You see that in the picture A, the dendrite. Here, the picture A means that human neuron, and picture B, we have the artificial neuron, and picture C is the biological synapse, and picture D is the ANN synapse. And when we take a look inside about the other one cell, we see that the neural network, artificial neural network, it means that is a network chaining process to chain the connection with and treehouse of neuron based on learning pattern to satisfy certain conditions. And in the INN, the micropropagation is a very important processing. It means that this process will update the weight by the formula, with the weight W is the weight of connection from neuron G to neuron I, and N it means that learning rate, and G is the current gradient. We have a lot of many kind of gradients, so that we have many kind of micropropagation. And take a look about the micropropagation in the neural network chaining. Yes, by micropropagation here we will update the weight, and we apply the activation here. And when the micropropagation will stop, when we have enough number, when we know that enough. We have enough number of efforts or is decided value or divergent target function, and we will stop the micropropagation. And activation function, you see activation function here. There are a lot of activation function of the time, the ReLU, signal, or linear. And if we don't apply activation function, it means that non-linear linear problem. However, actually, we had to solve non-linear problem, so that we need the activation. Yeah. And in the deep learning, you know that is the main part of machine learning. What is the difference between machine learning and deep learning? When you see in this picture, what is the difference between machine learning and deep learning? Yes, you see that clearly in the machine learning, the picture extraction and classification is separately. However, in deep learning, it's the same picture extraction and classification. And there are many different between the deep learning and machine learning. Here is some work. Here is explain more detail what is different between the deep learning and machine learning. For example, data. Deep learning needs the big data, and machine learning perform well with the small data. And the hardware requirement, deep learning needs more machine with the GPU. And for training time, deep learning takes a long time. And for processing, a number of algorithms, and for data interpretation, it's more difficult in the deep learning. However, in machine learning, some machine learning algorithms are easy to interpret. However, the other are hardly possible. And in 2019, three scientists they